thing when it falls, then a person can't move anymore, right?
Yeah. You alternate turns.
Alternate turns. Any one of them they flake on?
I actually don't think so.
So that's a good question for you. You just made up your own problem for Thursday.
That's right.
What?
Yeah, so honestly,
You know, be cool in a video. Just you ask it,
Mm.
and someone else answers it.
there's a finite number of moves.
Kind of.
Yeah, there is, right? Because there's no way that
you take away steps.
Yeah, you keep stacking it up, so kind of keep
that's physics, though. But then it makes it a game of chance, doesn't it? There's probability involved, isn't it?
Yeah,
That it'll
chances
fall
of things
that many
possible.
times.
You never know. Someone might stay.
So you can think of all kinds of games that you want to put in there that are or are not combinatorial games. And then I'll record you. So practice. That's my recommendation to you. How many of you commute to Montclair? Practice in the car.
That doesn't seem safe.
I do it all the time. People always think you're talking on the phone. And if they think you're not talking on the phone, you see a parting of the ways so you can get here faster. There's a crazy person. Left lane.
So it's all this? Even the normal play and the misery play?
No, it's I gave a list of 7 on one of the videos. Actual, like I went 1, 2, 3, 4, 5, 6, 7. It's a game of no chance. It requires 2 players.
Each player knows fully the details of the game.
Yes. So where would they not know fully the details of the game? I gave you guys examples of that.
I have to go back to the first video.
So I want to open up today. I told you the dots and boxes, the map was actually difficult. And I kind of let you struggle around with it. But it's not trivial. So I want to give you the correct answer. Kind of let you flounder around with that a bit. And this is just recording, so it's just a voice recording, and you get my screen, my desktop as the picture that goes with it. So in dots and boxes, we have, let's take the 4x4. The way you play dots and boxes is you make an edge between 2 vertices, right? So you're going to, let's do 2 colors here. So first player goes and they make an edge. Where does the computer like to go first? They usually like to do this, right? Make an edge right there. Right? So the domain of what you're doing, what you're placing something on, requires knowledge of the 2 vertices that you're putting the edge in between, right? The action that you're implementing on those 2 vertices is placing the edge between them. So you really need the coordinates of this vertex and this vertex as your domain. And then you're placing on top of it that edge. So the domain in this case, you numbered it. Sometimes I start from 0 and sometimes I start from 1. You could put a coordinate axis on there, make a Cartesian plane. What would the domain look like? What would an element from the domain look like? What would I need to know to put something there? Yes, I would need more than that, right? I have, for example, this one would be, it's an edge between the coordinates 1, 1 and the coordinates 2, 1. So the domain is actually the ordered pairs of these vertices that you're placing the edge into. Give me those 2 pairs of vertices, and then I can tell you what to do with them, with the edge between them. Right? So it's a little bit different. It was a little bit different. Somebody was confused. Maybe I take the spaces between the 2 because I'm making a box out of it. That's not quite what you're doing. You're actually making edges on top of each one of these vertices. So the domain is actually the set of the pairs of vertices. So it's an ordered pair of ordered pairs. I told you it was a little hard. And what would the range be? What are the y values? What's the action that you've done to those vertices?
Can you read red, blue, of course?
That's right, the colors. So the ranges are the same. So if this would be the same in your case with the triangle game, maybe something very similar, right? You have a set of vertices and you're placing edges between them. You're going to have to figure out how to set this machinery up in this way. It's very similar. I'm trying to think. Yours, you guys, Johnny, you guys have something that's already been set up. It's very similar to Go. They're taking domineering. Because you're changing your mind. They're taking.
We were thinking
Yeah.
about checkers.
Oh, yeah, that's fine. Do it on me.
Okay, but you change every day, so
Yeah, I know.
they got. You guys got NIM?
Yeah.
Right.
For now.
Did you bring your game in today? Okay, bring it in Thursday. Right, so we'll look and see if that's something that we can work with. So I would recommend getting your games down so that you can start the lit search. And remember, the lit search cannot be done in just Google searching because you actually need, I looked in this database, I would recommend something called MathSciNet, which our library has and our math department fought very hard to get. So on the in the Sprague Library, they have electronic databases. These are only math and computer science papers. Maybe there's some physics in there. So you can just go log in with your net ID and password and then use that database and search your game. So I'm getting questions also about the games.
Are you downstairs?
You know, if you choose something like Dots and Boxes as your game, well, Dots and Boxes, I mean, this, I don't know if I showed you the video of this guy, but I think he must be in his 70s now. And he spent a lifetime looking at Dots and Boxes with a zero teaching load. So he never had to teach. He just sat around and thought about Dots and Boxes. You probably won't be able to chip off something that he's not done and left as an open problem in the time span of our class. I don't believe in miracles. I'm a mathematician. I'm so rational. I don't believe in miracles. So, and I've actually tried it many times. I've done my Hail Marys and come into a final. It hasn't really helped me that much. Maybe I've sinned too much and it didn't work. I just told you I'm Catholic. I believe in the power of sin and cleansing and all that stuff. So I recommend that if you have something like old like that, that's Dots and Boxes, then you could look in MathSciNet. Many students like to work on projects like this and they publish their papers. You can take their papers, which probably is a variation off of Dots and Boxes that's more tractable. In fact, the triangularization that you're looking at is a variation off of Dots and Boxes. So you can pick something like that and you will find things. And the journals that have those kind of papers, the dominant journal is called Pi Mu Epsilon. You'll find, there's another journal, I don't know if it's in this MathSciNet, but it's called the Fibonacci Quarterly. And I'm just going to abbreviate it because I always misspell it. And if you can't find this journal, Fibonacci Quarterly, inside MathSciNet, you can just go to the website. It's like a dog and pony show. It's, even the text, the type to the setting was old style. So go there and just go into their search engine and see if you can find your game, any topic on your game. A lot of really like ad hoc kind of accessible material is published in Fibonacci Quarterly. So those would be the places to go. And I don't know if there's a combinatorial game theory journal, but there may be. You'll find it off of either MathSciNet or looking in these separate places. Pi Mu Epsilon is definitely indexed on MathSciNet. So that's where you want to start looking and reading and understanding what's out there, what's been proved already, what's been done, what can you carve out. And if you're not finding anything, I'm here for you to talk to so that you can go, oh, I looked at this, I'm not finding anything. I mean, that's what mathematicians do. Like, have you thought about this? You know, you see me do that all the time. I wonder what happens if we did this. Fooling around with the math. So I have no problem helping you with that. And you don't have to ask me in class or wait till class. You can text me or send me an email and I'll answer it. How many of you used text to contact me before? So easy. I answer it right away, don't I?
Yep.
I'm a caller.
You can call me too. I prefer calls because texting, I get a voice recognition thing in the car. And whenever I reply, it garbles whenever I reply. So. Okay, any questions? So Thursday, we're going to start our first round of videos, just definition of combinatorial games with examples and non-examples. Is this a better way to memorize definitions? The exhibitionists say, yes.
Me too, it's so manly. You ever listen to yourself back on like an